Okay guys, in this video we are going to talk about the application of MCT and MD using empirical rule, the one that we left out before. So in empirical rule, right, it is actually a statistical rule stating that for any symmetrically distributed data, this is the important point, meaning that empirical rule can only be used when your data, right, when you draw be in this shape. Alright, remember what the symmetry distribution looks like? Bell shape. If your data is skewed, then this can't be applied. We have a different rule, but it's not being emphasized here. So now we are talking about one of the rule of thumb that we can use, right, in describing data, which is empirical rule. Okay, empirical rule will use the MCT MMD, right, the one we have discussed before, which is this one, right. We are talking about this, right, this formula. We have mean plus minus standard deviation, mean plus minus 2 standard deviation, and mean plus minus 3 standard deviation. Okay, so given that your data is symmetry, okay, we can estimate, right, how much value that you have within each of this range without the need for us to count it one by one, right? Interesting, right? So for example, if you are looking at this, right, they are saying that by using the 3 sigma rule or the 68, 95, 99.7 rule, okay, we can actually describe the data, right? But it is just an estimation, it's not accurate. So for a data, given that again your data is symmetry, right, so a data that is within the range of mean plus minus standard deviation, so this is plus, this is minus, so you'll get this range. Maybe to apply it, we can use our previous example. So for the first standard deviation, mean plus minus 1 standard deviation, this is the range 2954 to 3.048. So basically this is the range of 2954 or 3.048, right? So we can say that 68% of the data is within this range, right? Is within this range. In other words, we can say that 68% of data is within this range, given that the data is normal. We can confidently say that. So let's say you have a 1000 data, we can say that 680 data are having this value, right? Without we need to look at each data individually. Okay, if we try to expand it further, right, we look at the 2 standard deviation, right, which is this range. We can say that 95% of the data value lies within this range. So if you plus all of this value, you will get 95%. So we can confidently say that 95% of our data fall within this range. So let's go back to our previous example. Basically, what it say that, right, for this one, sorry, if we talked about the range for two standard deviation, this is the range for previous example. So we can say that 95% of our data are having this value. Or if let's say you have 1000 data, 950 data is having this value. Okay, how about 3 standard deviation? 3 standard deviation talks about this range, which include almost every data, right, that may be left out. No, if you look at this, 0.3, 0.3, yeah. So if you are looking at 99, we look at 3 standard deviation, right? For our previous example, we can say that okay, 99.7% of our data are having this value. So for another 0.3 might be having a value that is less than this or more than this. So that is what we can say by using just empirical rule, without even we don't even need to look at the data, right? Given that your data is symmetry. Okay, so if your data is not skewed, usually it will skewed, right? For real-time data, usually your data will not be symmetry, right? If it is symmetry, then you can use empirical rule to describe your data, right? If not, there's actually another rule. We call it Chebyshev theorem, but not covered here. So also talk about this kind of rule of thumb, right? But we're not going to cover that. Okay, so that is about the application of MCT and MD, right, by using empirical rule. Thank you.